Hello friends, in this circuit we are asked to find Norton equivalent between A and B. Okay, these two terminals we have to find the Norton equivalent and four options are given and we have to choose the correct one. So in Norton equivalent what we get across two terminals, okay, say across these terminals A and B in this case, we will get a current source. Okay, we have to reduce this circuit into a current source, okay, in parallel with the resistance. Okay, it is not an equivalent resistance. Okay, and these are my terminals A and B. So what I need to find is IN and RN. If I get my current, not an equivalent current, okay, and my resistance, not an equivalent resistance, then I have my circuit. Okay, so let us proceed and find it. So first I'm trying to find not an equivalent resistance. Okay, so for that what is the procedure? The procedure is to replace the voltage sources and current sources, okay, which are independent, independent voltage source and current sources by their equivalent resistance. So this 2 volt is a independent voltage source, so I have replaced it by a conductor here. Okay, because its internal resistance is 0, so it's a simple conductor. But you can observe here that this dependent current source is kept as it is. Okay, it's not replaced. Please be careful, don't replace the dependent current or voltage sources. So this dependent voltage source is not replaced here, it's just kept as it is. Okay, now these two terminals A and B, okay, across A and B I need to find my Rn. Okay, so I'm trying to find my Rn. Okay, so first I'm trying to find my Rn. So what I am doing here is I'm connecting a 1 volt source. Okay, this can be any voltage. Okay, so if I calculate my Vs over Is, okay, say the current flowing out of this battery is Is, then that ratio is going to be my Rn. Okay, so the task is to calculate my current Is. Okay, because Vs I have already made it 1 volt. Okay, so if I calculate Is, then I can calculate my Rn value. Okay, so here you can observe that this Is is simply the sum of this current I1 and I2. Okay, I1 is the current which is flowing across this 1 ohm resistor, so I can write Is as I1 plus I2. Okay, so if I am able to calculate this I1 and I2, then I get my Is. Okay, so let us proceed and calculate our Is. Okay, so now what is I1? I1 is simple to calculate. See, this I1 can be calculated because simply as this voltage Vs is appearing across this 1 ohm resistor, so my I1 is going to be Vs over 1 ohm, which is going to be 1 by 1, because Vs I have taken as 1 volts, so it is 1 amp. Okay, so I1 is calculated. Now you can see once I1 is calculated, the value of this dependent voltage source can be calculated. So that is going to be 0.5 into 1, which is 0.5 volts. So now I can place here 0.5 volts. Okay, which is equal to 0.5 into 1 amps, which is flowing in this circuit. Okay, now you can see here that equivalent circuit is going to be like this. Okay, now I can calculate this current I2. how how I can calculate, because this voltage Vs I know, and I can again apply KVL here. Okay, so what I get is Vs equals I2 into 2 ohm. Okay, this resistor 2 ohms plus 0.5. Okay, this dependent current source, voltage source, this is 0.5 volts. Okay, from here if I calculate my I2 by putting Vs is equal to 1 volts. Okay, so if I put Vs is equal to 1 volts, okay, then my I2 is going to be 1 minus 0.5 by 2. Okay, and this is going to be 0.5 divided by 2, or 0.25. Now is equal to I1, which is 1 amps plus 0.25 amps. So my Rn is simply Vs over Is, so that is 1 over 1.25. Okay, because this is 1.25 is. Okay, so my Rn, if I write, it's going to be 0.8 ohms. Okay, so my Rn is calculated now. Okay, now what I need to calculate is my In. Okay, so let me write here, my Rn is already calculated, which is 0.8 ohms. Okay, so already you can see D is matching with it, but let's go forward and calculate our current source value. Okay, so what we do for calculating the current source value is we short the terminals. Okay, so I'll short these two terminals A and B. Okay, and then we'll find what is the current flowing. So now you can see here that if I short this terminal here, the path, this path is of no use, because this path, the current is not going to flow. So only this path is going, the current is going to flow only across this path. So I can say that I1 is 0, I1 equals to 0. Okay, so now the circuit reduces to, see, this value, which is 0.5 into I1 is again 0. Okay, and this is my 2 ohms. Okay, and this is my 2 volts, and this is, these are my two terminals A and B, and across this terminal it is shorted. Okay, so now if I again, this dependent voltage source is going to be 0 volts. Okay, because this I1 is 0. Okay, this I1 is 0, so this is again going to be 0 volts. So what I get here is only a 2 ohm resistor in series with a 2 volt uh, voltage source. Okay, so this is my uh, circuit now. Okay, now I need to calculate this In. So In is simply 2 by 2 is equal to 1 amps. Okay, so my In is 1 amps and Rn is 0.8 ohms. So my equivalent circuit is going to be this current source 1 amps in parallel with resistance of 0.8 ohms. Okay, across A and B. So if you see here, D option matches with this. Okay, so D is the correct answer for this question. Okay, so this is how you have to solve a question where you are given a dependent voltage source or current source. Okay, just remember that, don't replace it with, don't replace it or don't remove it while calculating your impedance. Okay, or your Norton equivalent resistance. Okay, so thanks for watching.